In this video, we'll discuss about the least count. What is least count in Vernier caliper? Simply, least count is the smallest measurement or smallest length that Vernier caliper can measure accurately. It is the smallest length that Vernier caliper can measure accurately.
Now we will discuss what is zero error in Vernier caliper. When the jaws of Vernier caliper are completely closed, the zero of the main error and the zero of Vernier scale should exactly match. If they do, there is no error. But sometimes, even when the jaws are completely closed, the zeros do not align. This is called as zero error. See, this is the example of zero error, no correction needed. Means when both zeros align perfectly. This is the zero of main scale and this is the zero of Vernier scale. They both align. This is ideal case. Okay. But there are two types of error, positive error and negative error. This is the example of positive error. When zero of Vernier scale is ahead of main scale zero when jaws are closed. See, this is the main scale zero and this is Vernier scale zero. The zero of Vernier scale is ahead of zero of main scale. So what we have to do is correct reading. The formula of correct reading is observed reading minus zero error. You have to subtract that zero error from the main reading. Okay. If negative error is present, what is negative error? When zero of Vernier scale is behind of main scale zero, when the jaws are closed. This is the main scale zero and this is Vernier scale zero. This Vernier scale zero is behind the main scale zero. This is negative error. This is main scale and this is Vernier scale. So the correct reading is observed reading minus negative of zero error. So minus minus became positive. By taking the example, I will tell you how to find the error.
In this case, you don't need to calculate it. If least count is not mentioned, there is a formula to calculate the least count. How will you calculate the least count? The formula is least count equals to value of one main scale division minus value of one Vernier scale division. Simply you have to subtract main scale division minus value of one Vernier scale divisions. So suppose if there are 10 Vernier scale divisions equals to 9 main scale divisions. So the least count is 1 by 9 minus 1 by 10. The answer is 0.01 centimeter. This is the least count of Vernier scale.
Now we will discuss how to take the reading. Step number first is note the main scale reading. How will you note the main scale reading? Note the main scale reading just before the zero of the Vernier scale. This is the main scale reading. Step number second is you have to find the Vernier scale reading. Identify which division on the Vernier scale aligns exactly with the division on the main scale. Step number third is multiply the Vernier scale division with least count. Okay. The step number fourth is total reading equals to Vernier scale reading plus main scale reading. This is the final answer if there is no zero error. Now let us discuss with the help of an example. Okay. Step number first, you have to find the main scale reading. Look at the main scale just before zero of the Vernier scale. This is main scale and this is Vernier scale. This is zero of Vernier scale. So this is the reading of main scale. How will you find? This is 10, 11, 12, 13, 14 and 15. So the main scale reading is 15 mm. Step number second is Vernier scale reading. You have to find the coinciding division on main scale and Vernier scale. Suppose in this case, this division is coinciding of main scale and Vernier scale. You have to calculate this reading. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. This 16th division is the coinciding division. Now what we have to do is multiply the coinciding division with least count. Okay. Suppose in this case least count given is 0.05 mm. So the reading of Vernier scale is 16th division into 0.05, the least count. The answer is 0.8 mm. This is the Vernier scale reading. So the total reading is main scale reading plus Vernier scale reading. Main scale reading is 15 and Vernier scale reading is 0.8. So the answer is 15.8 mm. This is the final answer if no zero error is present. If the error is present, There are two types of error, positive error and negative error. Zero error means if the main scale 0 and Vernier scale 0 coincide with each other. But in this case, there is positive error. Positive error means if 0 of the Vernier is ahead of the 0 of main scale. This is 0 of main scale and this is 0 of Vernier scale. So the 0 of Vernier scale is ahead. Okay, so this is positive error. Then what you have to do is error. You have to find the positive error. The formula is coinciding division multiplied by least count. Suppose in this case, this division is coinciding. So to find the value, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Ninth division. So coinciding division is 9 multiplied by least count, which is 0.05. The answer is 0.45 mm. So the final reading is observed reading means the total reading minus zero error. Observed reading is 15.8 mm minus zero error 0.45 mm. So the final reading is 15.35 mm. This is the final answer. If zero error, positive zero error is present. If in case negative zero error is present, means if zero of Vernier is behind the main scale. This is negative error. This is the zero of main scale and this is the zero of Vernier scale. So the zero of Vernier is behind the main scale 0. This is negative error. This is positive error when zero of Vernier is behind. Ahead, sorry, zero error. Zero, the main scale 0 and the Vernier scale 0 are coinciding with each other. This is zero error, this is positive error and this is negative error. So how to find the reading if negative error is present? Same, the step number first is find the main scale reading. Suppose if main scale reading is 20 mm. The step number second is Vernier scale reading. Coinciding division multiplied by least count. If the coinciding division is 6 and the least count is 0.1. So the Vernier scale reading is 0.6. What we have to do is main scale reading plus Vernier scale reading means 20 plus 0.6. The answer is 20.6. But in this case, zero error is present. How will you find the negative error? Coinciding division into least count. Suppose coinciding division is 3 and the least count is 0.1. So the answer is 0.3. The final reading is observed reading minus of zero error because there is negative error is present. Minus minus became plus. So the final reading is 20.6. This 20.6 minus 0.3 means 20.6 plus 0.3. The answer is 20.9 mm. This is the example of negative error and this is positive error.